this session, we will do questions related to topic moles, and we already discussed that how to solve questions related to moles. There are two ways to solve the question related to moles. One is by using the ratio from the equation, and the second method we can use a formula. So you have to recall the three formulas which we discussed in the last session. The three formulas which we discussed in the last session. The first one, moles equal mass in gram divided by molar mass. Molar mass means it can be atomic mass, it can be a molecular mass. A mass of 1 mole is called a molar mass. That's the first formula. The second formula, that is moles equal concentration or amount of solution multiplied by the volume of solution in decimeter cube. So this is the second formula, and it is normally used for the solutions. And the third formula, that moles is equals to volume of the gas in decimeter cube in dm cube divided by 24. So but keep in mind this is only valid for gases. So mass in gram, if mass is given, we can use the first formula. If concentration and volume are given, we can use the second formula. And if volume of the gas is given, we can use the third formula. And same way we can relate if we have the moles and molar mass, so we can find mass in gram. So now we'll do questions related to the topic moles, and we'll solve question from by both ways. Either we will use a ratio to solve the question or the formula. So this is the MCQ which we did in the last session as well. So I will just quickly go through this. As you can see in this question, first thing you have to know what is given to you. The concentration or amount of hydrochloric acid is 0.5 mole per dm cube. So you have the concentration which is 0.5 mole per decimeter cube. How many moles are there? So we have to find moles in 25 cm cube of the solution. So volume of the solution, that is given 25 cm cube. So what we have to do, because we need the moles, we have the concentration and volume. So the formula which relate the concentration and the volume, that is the second formula. The second formula states that moles is concentration of the solution multiplied by volume of the solution. So the concentration of the solution multiplied by volume of the solution, as in the question the concentration is given 0.5. Now what about the volume of the solution? The volume of the solution is 25, but that is in cm cube, so you have to convert the volume from cm cube to decimeter cube. And how we convert the volume from cm cube to decimeter cube? We will divide by 1000. So this 25 will be divided by 1000. So 25 divided by 1000, that is 0.025 decimeter cube. So always the volume you have to convert. If you are using a formula that concentration into volume will give us the mole, so the volume will be 0.025. So when we multiply 0.5 multiplied by 0.025, so it will come out as A. Is it clear, this question? Is it clear to everyone? The question that how to we work out the number of the moles. We use the formula of concentration of a solution multiplied by volume. The concentration was given 0.5 and the volume is 25 cm cube, but it should always be in decimeter cube. Okay. In this question, actually the first part, this part is related to acid topic, so we will not attempt the first part, we will skip that and we will solve only the mole parts. But the reason why it is shown here, because you need the equation for that, so I will complete the first part for you. But when we'll discuss the acid chapter, you will be able to complete this equation. So sodium hydroxide react with sulfuric acid. This will form sodium sulfate plus water. This is a balanced equation. Because we need the equation to solve the second part related to moles. In the second part, leave this one as well, the titration, because that is related to acid as well. Calculate the concentration of sulfuric acid. So we have to calculate the concentration of sulfuric acid using the following steps. So we have to follow the steps to get the answer. It's not like directly we will get the answer. We have to follow the step to get this answer. So first they are saying calculate the number of moles of sodium hydroxide in 25 cm cube. So if you read the question, a student want to find the concentration of some dilute sulfuric acid by titration. Titration is a technique by which we find the concentration of different substances. The student found that 25 cm cube of 0.04 mole per dm cube sodium hydroxide reacted with 25 cm cube of H2SO4 or sulfuric acid. So in the question, we have to, the first part of the question, we have to calculate the number of moles of sodium hydroxide. How to get the number of moles of sodium hydroxide? So we have the volume of sodium hydroxide. If you read the question, this is a volume of sodium hydroxide, which is 25 cm cube. But that should be converted into dm cube. So what we do, we divide by 1000. So 25 divided by 1000, this will be equal to 0.025 decimeter cube. So that is the volume of the solution. And what about the concentration of sodium hydroxide given in the question? It is having a concentration of 0.0400 mole per dm cube. So this is the concentration. So the concentration I am writing CONC, which is equals to 0.0400 mole per dm cube. So in the question, we have the volume of sodium hydroxide and we have the concentration of sodium hydroxide. So what we can do to get the moles? So we'll use a formula. And what formula we will use? We'll use the formula moles equal concentration. I'm writing in short C and the volume is V. So moles equal concentration into volume or C into V. In exam, you can also write in short. That is acceptable. And to represent the moles, you can use the letter small n. So n is equals to C into V, or if n is confusing, you can say moles equal C into V. So moles equal concentration into volume. What is the concentration of sodium hydroxide? That is 0.04 multiplied by volume of sodium hydroxide given in the question, 25 cm cube or 0.025 dm cube. So when you multiply these two numbers, what you will get? You will get the moles of sodium hydroxide, which will come out as 0.001. Is it clear, the first part? Anyone having a question or a doubt in the first part? Is it clear, the first part of this question? So we have the volume of sodium hydroxide and we have the concentration. We got the moles. The second part, deduce. Deduce means find the number of moles of sulfuric acid. So that reacted with 25 cm cube of sodium hydroxide. So how we can work out the moles of sulfuric acid? Sulfuric acid means H2SO4. So we have the moles of sodium hydroxide and we need the moles of sulfuric acid. So what we can do for this part, we can use the ratio. So what is the ratio between sodium hydroxide and sulfuric acid H2SO4? If there are 2 moles of sodium hydroxide, there should be 1 mole of sulfuric acid. But in the question, how many moles of sodium hydroxide are there? In the question, we have 0.001 moles. So how many moles of sulfuric acid will be there? X. So we cross multiply. 2 will multiply it with x and 0.001 multiplied with 1. So it will be 2x is equals to 0.001 and x will be equal to 0.001 divided by 2, which is equals to 0.0005. So that will be the moles of sulfuric acid that will react with the moles of sodium hydroxide. Is it clear the second part? Anyone having a doubt or a question in the second part? So first we use a formula. Why we use a formula? Because the concentration and volume was given for sodium hydroxide. That's why we use the formula. But for second one, for sulfuric acid, we don't have its concentration. We have only its volume. The volume of sulfuric acid is given, but we don't have concentration. So we cannot use the formula. That's why we use the ratio. So we have sodium hydroxide and we are finding sulfuric acid. The ratio according to equation is 2 is to 1. So if 0.001 moles of sodium hydroxide, then x moles of sulfuric acid will be there, which will be 0.0005. Then the last part, we need the concentration. So how we can get the concentration? We have the formula that moles equal concentration into volume. So if we want the concentration here, we have the moles for sulfuric acid from the previous part, which is 0.0005. Concentration is unknown. And what about the volume of sulfuric acid? The volume of the sulfuric acid is 20 cm cube. That is given in the question, 20 cm cube. So we have to convert into dm cube. So it will come out as 0.02. So it will be 0.02. And if we need a concentration, 0.02 is multiplied. Other side it will divide. So 0.0005 divided by 0.02. So 0.0005 divided by 0.02, that will give us the concentration of sulfuric acid, which will come out as 0.025 moles per decimeter cube. Is it clear? The last part, how we work out the concentration. We have the moles, we have the volume, so we worked out the concentration. Any question or a doubt in this part? Yes, Abdullah Khan, Afreen, Bashira, Hiba, Nourish, Bizat, Yusra. Any doubt in this part? So I'll repeat what we did here in this question. First, we have to find the moles of sodium hydroxide. The main question is we need a concentration, but we have to follow their steps. So first part, we have to calculate the moles of sodium hydroxide. So for moles of sodium hydroxide, the volume of sodium hydroxide is given and its concentration. So concentration multiplied with volume, we got the moles of sodium hydroxide. Then we need the moles of sulfuric acid. But about the sulfuric acid, only thing what we have is volume. We don't have its concentration because we need concentration and volume both to get the moles. So we have its volume, sulfuric acid, that's 20, but we don't have its concentration, so we cannot use a formula. So if we cannot use a formula, what we can do, we can use a ratio. And what ratio we took, because we have sodium hydroxide and we are finding sulfuric acid, so given is sodium hydroxide and required is sulfuric acid, so we can take a ratio between sodium hydroxide and sulfuric acid. Sodium hydroxide, there are 2 moles according to equation, and sulfuric acid, there is 1 mole. So ratio between them is 2 is to 1. But in the question we have 0.00 moles of sodium hydroxide. Then how many moles of sulfuric acid should be there? X, when we solve, will get 0.0005. So these are the moles of sodium. These are the moles of sulfuric acid. Now we have the moles, we have the volume. So we need a concentration. So moles is concentration into volume, or concentration is mole divided by volume. So we'll get its concentration as 0.025. This question is related to empirical formula. Sulfur dioxide react with sodium sulfide to produce a compound which is having a composition percentage of sodium is 29.1, sulfur is 40.5, and oxygen is 30.4. We need the empirical formula of this compound. So to get the empirical formula, there are 3 steps. We have sodium, sulfur, and oxygen. Sodium is 29.1%, sulfur is 40.5, and oxygen is 30.4. What is step 1? The step 1 is divide by atomic mass. So we'll divide each of them by their relative atomic masses. So for atomic mass, what we have to do, we have to check the periodic table. So this is a periodic table. We have sulfur, we have sodium, and we have oxygen. So when we check sulfur, here is sulfur. So what is the mass? The key is given. So atomic mass is given at the bottom. So sulfur is 32, oxygen is 16, and sodium is 23. So we'll divide each percentage by its mass. So step 1. So we have sodium, sulfur, and oxygen, 29.1, 40.5, and 30.4. Divide by atomic mass. So sodium is 23, sulfur is 32, and oxygen is 16. When 29.1 divided by 23, that is equals to 1.265. 40.5 divided by 32, that's equal to 1.265. And 30.4 divided by 16, that's equal to 1.9. Then what we do, we divide by the smallest value. So the smallest value is 1 point. The step 2, divide by the smallest value in the combination to take the simplest ratio. So 1.265 is the smallest value. So when we divide them by their smallest value in the combination, so this will come out as 1, this will come out as 1, and 1.9 divided by 1.265, that's equal to 1.5. So one of the value, the step 3 is we have to make the simplest ratio in a whole number. So if one of the value is 1.5, 2.5, 3.5, what we do? We multiply all of them by 2. So when we multiply all of them by 2, it will be 2 sodium, 2 sulfur and 3 oxygen. So what is the empirical formula of this compound? So this compound contains 2 sodium, it contains 2 sulfur and it contains 3 oxygen. So the formula will be Na2S2O3. Is it clear? Okay, in this question, hydrogen peroxide, which is having a formula of H2O2, decompose into water and oxygen in the absence of a catalyst. Catalyst is a substance in the presence of catalyst, not the absence. In the presence of the catalyst, manganese 4 oxide, catalyst is a substance which speed up the reaction. And the equation for this reaction is given that 2H2O2 gives 2H2O plus O2. The student the student studies the rate of decomposition of hydrogen peroxide using the apparatus. The apparatus, I removed that apparatus because that's not related to our question. The student uses 20 cm cube of 0.1 mole per dm cube hydrogen peroxide. So this is the hydrogen peroxide which he used. So 20 cm cube. So volume is given, which is 20 cm cube, and 0.1 mole per dm cube. So concentration is given, which is 0.1 mole per decimeter cube. In the first part, they are asking calculate the number of moles of hydrogen peroxide used in this experiment. So we need the moles of hydrogen peroxide. If we have the volume and concentration, so if we have volume and concentration, we can use a formula to get the moles. That moles equal concentration multiplied by volume. So concentration is 0.1. But what about the volume? The volume is given in cm cube. So we should always convert into decimeter cube. To convert this cm cube into dm cube, we divide by 1000. So it will be 20 divided by 1000, that is 0.02. So the volume in decimeter cube is 0.02 and the concentration is 0.02. So concentration is 0.1 and the volume is 0.02. So when we multiply them, we'll get 0.002. Is it clear, the first part? Anyone having a question or a doubt? Any doubt related to the first part, as we have the concentration and the volume, so we can multiply them to get the moles. Now about the second part, you can see use your answer to C1. Use your answer to C1. You have to calculate the number of moles of oxygen in the reaction. So how to get the moles of oxygen? Look, about oxygen, nothing is given in the question. So if nothing is given or information is incomplete, we use a ratio. So which ratio we'll use? Because we already have hydrogen peroxide and we need oxygen. So what we have and what we need, or what is given and what we have, what is given and what is required, we can take that ratio. So what is given to us, hydrogen peroxide is given, and what we require, oxygen. So when you check the equation, hydrogen peroxide, if 2 moles of hydrogen peroxide are there, then there will be 1 mole of oxygen. So ratio is 2 is to 1. But how many moles of oxygen, how many moles of hydrogen peroxide are there in the question? So we have the three formulas related to moles. These are the three formulas which are related to moles. Number one, if you want the moles, it is mass in gram divided by molar mass. Number two, it is concentration of a solution multiplied by volume. And number three is the volume of a gas in dm cube divided by 24. So these are the three formulas which you have to learn or memorize related to moles. So as you can see in the first part, as you can see in the first part, they're asking calculate the number of moles of hydrogen peroxide. Hydrogen peroxide is H2O2. So we have to find what is given to us. So when you read the question, student studies the rate of decomposition of hydrogen peroxide and he uses 20 cm cube. So he is having the volume of hydrogen peroxide which is 20 cm cube. But we have to convert all the volumes in dm cube, so it will be divided by 1000, so it will be 0.02 decimeter cube, and 0.1 mole per dm cube, so that is a concentration. 0. Mole per dm cube is a unit for concentration, so concentration is 0.1 moles per decimeter cube. So we have the volume and we have concentration, we need the moles. So how to get the moles? The formula that moles equal concentration multiplied by volume. So concentration in the question is 0.1 and the volume of hydrogen peroxide is 0.02. So when you multiply these two numbers, 0.002 will be the answer. That was the first part. That because we were having a concentration and the volume, so we multiply both of them and we got the answer. But the next part, they're asking number of moles of oxygen. But look, to use the formula to get the moles of oxygen, as we know there are three formulas: moles equal mass in gram divided by molar mass, moles equal concentration into volume, or moles equal volume of the gas divided by 24. But in the question, nothing is given related to oxygen. You don't have any information, so you cannot use a formula here. We don't have the mass of oxygen. This is the mass of manganese oxide, but not only oxygen. So we cannot use the first formula. We don't have concentration and volume, so we cannot use the second formula. We don't have the volume of the gas, we cannot use the third formula. So we can, to solve the second part, we cannot use a formula because the information is not there about related to formula. Then what we can use a ratio. What ratio we can use? Because we already worked out hydrogen peroxide, so we can take a ratio between hydrogen peroxide and oxygen. So if you see the question, if there are 2 moles of hydrogen peroxide, there will be 1 mole of oxygen. But if we have 0.002 moles of hydrogen peroxide, how many moles of oxygen will be there? X. And then we cross multiply, 2 multiplied by x, it will be 2x, and 0.002 multiplied by 1, so it means 2x is equals to 0.002, and we need this x, the mole, so x will be 0.002 divided by 2, which is equals to 0.001. Is it clear, the second part? Is it clear to everyone? So because the information about oxygen is not complete, so we cannot use any formula. That's why we use the ratio. Then the next part, they're asking volume. Calculate the volume. RTP means room temperature pressure. It's a short form for room temperature and pressure. So RTP refers to room temperature and pressure of oxygen gas produced. Now, how we can get the volume of oxygen? So we have the formula that moles equal, so we have the formula moles equal volume of gas divided by 24. So I have the moles of oxygen in the previous part. I got the moles of oxygen which were 0.001. Volume of the gas I'm finding, and volume 20 divided by 24, so it will be multiplied. So 0.001 multiplied by 24, so that is equals to 0.024 decimeter cube. So we use the formula to get the third one because we have the moles. So if we have the moles, we can find the volume of the gas as moles multiplied by 24 will give us the volume of gas. So that is how we solve the third part of this question. Is it clear to everyone? This third part, how it is done? So it depends on, if information is complete, you will use a formula. If information is incomplete, you will use the ratio. Okay, the next one, the next question. A student heated 10-gram sample of barium carbonate. So he's heating a 10-gram sample of barium carbonate until it is fully decomposed. Calculate the number of moles. So if the formula which relate, the previous question, first we have to find the moles, the volume was given, and the concentration is given. So to get the moles, we use the formula concentration into volume. The concentration is 0.1 and the volume is 20 cm cube, which is 0.02 dm cube. So when we multiply, we got the moles of hydrogen peroxide. Now we have the moles of hydrogen peroxide, we need moles of oxygen. So we use a ratio here, the ratio between hydrogen peroxide and oxygen, that's 2:1. So if we have 0.002 moles, then it will be X moles of oxygen. We cross multiply, we got 0.001 moles of oxygen. The third part, we need the volume of the gas. So how to get the volume of the gas? There is a formula that moles equal volume of the gas divided by 24. So we have the moles of oxygen in the second part, that we have 0.001 moles of oxygen. We need the volume of the gas, and that is divided by 24. So if 24 is divided, other side it will be multiplied. So 0.001 multiplied by 24, that will give us 0.024 decimeter cube. So this formula is valid to get the volume of gas or relate the volume of the gas with moles. So the three formulas you have to memorize, that moles equal mass in gram divided by molar mass. If mass is given and the formula is given, you can use this formula. So basically this formula relate mass in gram with moles. The second formula, moles equal concentration multiplied by volume. And the third formula, moles equal volume of the gas divided by 24. So these are the three formulas which you have to memorize. So moving on to the next question. We have 10 gram sample of barium carbonate. So we have the mass of barium carbonate. We need moles. So what is the formula which relate moles with mass? So moles equal mass in gram divided by molar mass. So mass in gram divided by molar mass. Mass in gram is 10. But what about the molar mass? Molar mass means the molecular mass or atomic mass. So we have to find the molar mass of barium carbonate. So barium carbonate, BaCO3. So what you have to do, you have to use a periodic table for this. So when you check the periodic table, we have to find the mass of barium carbonate. So barium is there. What is the mass of barium? 137. Because we want the total mass of barium carbonate, the molecular mass. Barium is 137 plus carbon is how much? 12 plus oxygen is how much? 16, and that is multiplied by 3. So 16 multiplied by 3, 48 plus 12, 60, 60 plus 137. So total will be 197. So the total mass of barium carbonate will be 197. So how we get the answer? Because the formula moles equal mass in gram divided by molar mass. Mass in gram is 10 and molar mass is 197. So how many moles we get? We'll get 0.0508 moles of barium carbonate. Is it clear? Is it clear this part? The number of moles of barium carbonate? Anyone having a doubt in the first part? Yes, Abdullah. Look, the mass is given and we need the moles. So we have the formula moles equal mass in gram divided by molecular mass. Mass in gram is 10. And what about molecular mass of barium carbonate? Barium is 137 plus carbon is 12 plus oxygen is 16 multiplied by 3. So it will be 10 divided by 197, which will come out as 0.0508. The mass in gram is given, the mass is given, and we need the moles. So we use the formula mass in gram divided by molar mass. So mass in gram is 10 and molar mass, the mass of 1 mole of a compound, that is using a periodic table we worked out and we got 197. So I'll continue this question, share another link.